Hey guys, welcome to another LeetCode tutorial. In this video, we are looking at LeetCode's problem number 69, that is the square root problem. The problem statement is you are given a non-negative integer x, which is the parameter that goes into our function. And what we need to do is we need to return the square root of x, rounded down to the nearest integer. And the return integer should be non-negative as well. Okay, and the main thing to note here is you must not use any built-in exponent function or operator. Be it I'm doing it in JavaScript, there's a function .math.square root to determine that, but yeah, you shouldn't be using any built-in functions. That's the idea of it, and you should be able to uh, build this solution without using those built-in functions. Okay, now let's talk about the approach. It's pretty straightforward in terms of understanding the question. It's basically just to give out the square root, right? Square root of a given number. So in terms of the constraints, the number x can be 0, anywhere from 0 to 2 power 31 minus 1. So we need to have a base condition check. If it is if the x is 0 or 1, you just return x, because that for 0 and 1, 0 and 1 are the square roots respectively, right? For 0 and 1 uh, numbers. So let's try to understand the cases for other numbers. So how do we go about solving this? For example, if x is 6, right? How do we figure this out? We can we can start by like one of the brute force approaches is we need to know the we need to start off with a number and then multiply it with the same number and check if it is 6 or not, right? As long as the square, so let me call it square, right? The square is basically um, some number into the same number, which should be equal to x, right? Then num is supposed to be the square root, okay? And then square is num into num, which is x, okay? Now we have to determine num. For that, you can do 1 into 1, which is 1, that is less than 6, okay? Then you can increment and go to 2, 2 into 2, that is 4, which is less than 6. So our square root, nearest square root is 2. Now we can increment further since 4 is less than 6, and then do 3 into 3. 3 times 3 is 9. So that is greater than 6. So our nearest square root for 6 will be 2. Okay, but imagine a bigger number. We'll have to go, if we are going in this order, it's going to take a lot of time, which is like to determine it in O of n times, right? Which is in linear complexity. We can further narrow it down and make it faster by using binary search. So I'm going to be talking about the binary search approach now. So let's take an example of x equal to 15. Okay, now what we can do is we know our lowest number can be 1, and the highest number we can start off with x by 2. Okay, so that will be 15 uh, 15 by 2, that is 7, right? And then we can start off with this approach of binary search, where you can uh, go by low, less than or equal to high. Let me just call this high. So that will be our while loop with while low is less than or equal to high. Then we are going to be using calculating the mid. Let mid equal to low plus high divided by 2. And then we are going to use a math.floor on this, so that we'll get the we can get rid of the decimal. Okay, so this will be our mid, right? In this case, 1 plus 7, that is 8, 8.1 plus 7.5, right? That is 8.5. by 2 will be 4 something, and then we can get rid of the decimal. Let me just move this out here. Okay, so this will give us 4 as our mid, right? Now all we have to do is we'll have to compute the square. The square will be const square equal to mid times mid. Okay, now if square is equal to x, then we have found the square root, right? Then you simply return uh, the mid. Otherwise, if square is greater than x, that means um, the mid value needs to be reduced, the highest value of the mid, right? So the right now we have calculated high, but we need to update our high to mid minus 1. If you know how binary search works, this should be pretty straightforward to understand. Um, Otherwise, it's going to, what we need to do here is we can let's use another variable to maintain our square root. Square root equal to, it could be 0 first, and then we can just say square root equal to mid. We don't need to return here. And then if yeah, you can just break out of this loop. And if it is greater, if square is greater than x, you just decrement you can set the high to mid minus 1. Otherwise, you can set the low to mid plus 1, right? You are incrementing the lower part to mid plus 1. And the other thing you could do is the nearest square root will be mid. If it is lower, you are still you can, for example, in while we were computing it for 6, we tried for 1. So 1 is less than 6, so we'll be updating our square root to the nearest square root to 1. And then we have tried it with 2, which is still less than 4. So we are immediately going to update our nearest square root to 2. And then we've tried it with 3, but the value of 3 times 3 is greater than 6, so that's why we return square root equal to, nearest square root is equal to 2. Similarly, like whenever it is low, we just update the square root with the current mid, and then we increment the lower pointer to mid plus 1. I hope this is clear. Um, you can go back and rewatch it again if that was confusing. And then once we have everything that we need here, uh, the high pointer or the high value will at some point will be less than the low pointer, and that's how the while loop breaks. And that time you just return square root. So this should work well for our solution, and it's going to return either the exact square root if it finds the exact match. Otherwise, it's going to give you the nearest square root. Um, by the time the while loop breaks, it's going to give you the nearest square root. Okay, so this is how for x equal to 15, we should be getting 3 as our output. Let's try this out within our code. Okay, first and foremost thing that I will do is I'll check if x equal to 0 or x equal to 1. I'm just going to say return x. That will be my square root. Otherwise, I'm going to be creating, let me copy this. I'm going to be creating a variable called low equal to 1, and high will be x by 2. That's where I'm going to have my low and high pointers. And going over the for loop, I'm going to calculate mid first, and then calculate the square with that mid, and after that I'm going to be using the binary search conditions equal to, greater than, or less than, based on the condition that the control flow gets into. I'm going to be updating the high and low pointers. and if I find the exact match, I'm going to break out of this loop and return the square root. Okay, so that's how the solution works. We can actually do a rundown of this step by step before I run the program, because I feel I'll have to somehow I have to repeat this for someone who doesn't know binary search very well. This example might be pretty useful. So I'm going to do it one more time. So my low will be 1, and my high will be x by 2, which is uh, 7.5. Okay. Now my mid will be 1 plus, it'll be 1 plus 7.5, that is 8.5 by 2, that will be 4 point something. So my mid will be 4 because I'm doing a math.floor here. And then I'm going to be doing a square operation. If you're looking at this, square will be equal to 16. So 16 is not equal to x. X is 15, so 16 is actually greater. So I'm going to be moving my high pointer to my mid minus 1. So in the next iteration of the while loop, my low will be 1, my high will be uh, mid mid minus 1, which is 3 in this case, and my mid will be 1 plus 3, 1 plus 3, which is 4 by 2, that is 2, and my square will be 4. Okay, my square right now is less than the value of x, right? So that means I'm going to go into my else condition here. Okay, this time what I'll do is I'm going to update my square root to my mid. Okay, so my square root, nearest square root would be 2, and this is current mid. And then what I'll have is I'm going to increment my low. So my low will be low is equal to mid plus 1, that is 2 plus 1, that is 3. Okay, so in the next iteration, my low will be 3, my high also is 3. Now my while loop will still run because low is less than or equal to high is the condition, so it will still run. It will get into this. Now what happens is I'm going to calculate the mid. Mid will be 3 plus 3 by 2, that is 3, and the square is 3 times 3 is 9, and my okay, 3 times 3 is 9. Now 9 is less than 15, so it will come to the else part again. So it's not equal, it's not greater, it is less than, so it's coming here. Now what happens is my square root will be my mid, right? I'm adding this here. My square root will be mid. This will be updated to my current mid, and then I'm going to increment my low to mid plus 1. That is 4. Okay. Now what happens is my low is 4 and my high is 3, which is this condition is no longer true now. My while loop will break, and all I'm doing is returning the square root. So the square root, nearest square root is 3. So for 15, the answer will be 3. Okay, so that is how it is work. It's going to work. So I hope this is clear to you guys. I'm going ahead and running this solution right now. Okay, it has worked for x equal to 4, x equal to 8. Let's also add the last condition that we just discussed, 15, to double check. Let's see what's, okay, the output is 3 as expected. Yeah, this is how you solve the square root problem without using any inbuilt functions. And the best way to do it is through binary search, and the time complexity of this is O of log n. which is logarithmic in nature. I hope this is clear to you guys, and I hope you have learned something out of this. If you have learned something out of this, please give this video a like and consider subscribing to my channel. Thank you so much for watching, and I'll see you in the next videos.